And often what happens is that that data ends up maybe on someone's computer, maybe it's in a spreadsheet. But then if you want to reuse that data, let's say I want to do research and I want to use the data of another researcher, then that often is not possible. So in this session, I will be talking about something called the FHIR guiding principles. And in a minute, I will tell you what those are about. Basically, they are guidelines for research data management. And then I will go over a example of how you could use FHIR to make your data fair. So that's what it's called when you apply those principles. That's called well, making your data fair. And I will end with mentioning the FHIR for FAIR implementation guide. I contributed to that, and part of the work that I'm presenting now is also in that guide. So this is a paper that was published in 2016. It's called the FAIR Guiding Principles for Scientific Data Management and Stewardship. And this is where the FAIR principles basically were born. And as you can see, so here it says 4,000 citations. Checked it this morning. It's closer to 7,000, almost 7,000 citations. And this really took off. It's almost, yeah, you see it everywhere. People are, even funders are now saying that you should make your data fair. So it's really something that people, well, everyone kind of agrees that this is important. And well, FAIR is an acronym, so it stands for Findable, Accessible, Interoperable, and Reusable. And I try to condense, so there are 15 principles, and I try to condense it on this slide, what they are about. So I will go over each of them and just tell, briefly what they mean. So with Findable, FAIR means that you should have identifiers for both your data and your metadata. You should have metadata, so data describing the actual data that you have. The metadata, but also the data should be discoverable. Then accessible means that you should have some kind of open communication protocol to access the data and metadata. That protocol should support authentication and authorization, and the metadata should be persistent. So that's a very important point, is that when the data is no longer available, you should still be able to look at the metadata and know what data was available. Interoperability, so interoperable is all about knowledge representation. So both a data model and a format to represent the data in a machine readable way. You should use terminologies wherever possible and make references to other data. So if you have a data set and it's related to another data set, then there should be a reference from that data set to the other data set. Eventually, what this is all about is reusable data. So having data that is reusable for humans, but especially for machines. So you should have a computable format that machines can reuse. If there's a license, it should be clearly stated, and the metadata. So that's kind of the first. So in the Findable, there's a principle that says that you should have metadata. Reusability then says that you should have rich descriptions, which kind of means that if you look at the metadata, you should be able to tell if that data is actually usable for you. So if you have a research question, you look at the metadata, it should give you enough information to make that decision. So is the data usable for me? The last part, so community standards, that's very important. These are guidelines, so you have to implement them. And if you look at it, so I said rich descriptions, you should have a communication protocol, you should use terminologies. That's not very clear what you mean by that. And I think maybe, if you ask that 10 different people, they will give different answers to what that means for them. So what you should do is define a community. So everybody in this room could be a community. Or a larger community, like a research area, and then make choices and basically implement those principles. So give it meaning. Now, what I did is I took a data set that is available on PhysioNet. It's called Mimic4 Emergency Department, which is a model of Mimic4. It's freely available. And well, basically consists of two parts. So you have this web page. If you read that, you can you get an idea of what the data is about. So they describe the data elements, the terminology that has been used, the author information. So basically all the metadata is on that page. And the data itself is available as CSV files. So you can download the data, and it has 6 tables, all of them having information about these emergency department admissions. And what I did was take this data set and apply FHIR to it, and then see, well, if you do that, what does that mean in terms of the how fair that data is? So on the left here, you see, so there's a script. You can load the data into a Postgres database. I then set up a FHIR facade server using FHIR and implemented basic read and search operations, so you can get the data out of the server as FHIR resources. Part of that was actually modeling the data, so mapping the Mimic ED dataset to FHIR resources. So I wrote profiles for those. And then what I will do now is just go taking each letter of FAIR and kind of showing you what parts of FHIR help here, or what parts of FHIR contribute to FAIR data. So for findability, we needed 3 things. The first is globally unique and persistent identifiers for both the data and the metadata. If you set up a server and you have a resource, then the logical identifier of that resource in combination with the base URL of the server, that gives you a unique identifier that then you can use to access the data. As long as the server is online, of course. If the server is offline, then that identifier would not work anymore. The business identifier, that's the part where you could take the identifiers from, in this case, the Mimic dataset, put them in there. And then there are resources that support canonical URLs. So basically a globally unique URI. Most of the conformance resources and the knowledge resources are examples of that support this URL element. I used, so that's what you see here. It's basically the first part of the metadata. So that's the capability statement that gives you the, so what resources does the server support, and what operations does the server support, linking to the structure definitions, so the actual data model, and the value sets. So what terminology is used in the data set. I see this kind of as that description on the Mimic of the Physionet page where you read about the data. All that information is now in your capability statement, your structure definitions, and your value sets as machine readable metadata. And adding to that, and I will explain why citation is between parentheses, you have information about who publishes the data set, contact information, authors, maybe also copyright. And for that, you can use the library resource, which is kind of a general purpose container. And you can store the metadata in there. Recently, since R4B, the citation resource was added provisionally. So it's not sure yet if that will stay, if that resource will stay in the specification. But that one is specifically for citing, let's say, scientific articles or scientific knowledge artifacts. And then, well, discoverable metadata, you can put the information to the FHIR server on, let's say, Physionet. You could use Simplifier to put your resource, well, your structure definitions, your value sets, maybe also your capability statement, and publish that on Simplifier. And I just visited a talk about Lantern. It's kind of an example. If you would have a list of API endpoints, that would also make them discoverable, and that's exactly what Lantern is doing. Well, accessibility, there are 2 things. So we want the metadata and the data to be retrievable via standardized protocol. Well, if you use FHIR and you implement the REST, so you use REST, then you would have HTTP as your protocol, and the RESTful API then is your standardized protocol. What's important to mention here is that FHIR data does not equal open data. That's why the protocols should support authentication and authorization. So that's important. Persistent metadata, I don't have an exact answer to this. So it means that if your data is no longer available, you should still be should still be able to access the metadata. If you published your metadata on a repository like Visionet, then that would be the case. But let's say you have a FHIR server that has your resources or your capability state, your metadata resources and the data resources. If that server goes offline, you can't access either of them. So I've been kind of thinking about this when I just give 2 examples here. So I was thinking, well, maybe you can set up a metadata server that acts as, as just a server that serves the metadata resources that points to the server that has the actual data. Another thing that I found on the website of Smile CDR is this thing called a FHIR gateway, where you would have a server. So as a client, it looks like you're just interacting with one server, but that server can then point to multiple servers. Something like this, I don't know the exact answer to this because it is important. So you should be able to take the data offline basically and have the metadata still available. But this could be something that could be a solution to this point. Interoperability is quite straightforward. So as I said, knowledge representation is about a data model and a representation format for your data. So the resources in this case is the data model. The JSON or XML representation is your machine readable format. RDF is also available, so I should have added that here. Terminologies is an important part of FHIR. So if you use codes in your resources, then you are applying terminologies. Terminology service, because the terminologies themselves should also be FHIR. So that basically means that if you use a terminology service, that makes sure that your URLs that you use to reference to the codes are themselves also FHIR. References to other data, well, if you use the FHIR resources that reference to other resources, that's basically the solution to that. Then reusability. Visionet, so in this case Mimic ED, they have a license. It's on their website. It's a natural language or free text license. You could store that in the library or citation resource. Rich descriptions, so having enough metadata that you can determine if the data is actually usable for you. You have the provenance resource, so some resources store provenance information. If you need to store more provenance information, you could use the provenance resource as well. And the last point, so having community standards, I think there FHIR is one of the answers. So if you use FHIR, that's actually your community standard and solves a lot of these problems for you. And implementation guides can help here. So if you define a community, you have a common data model, let's say you have a common data model, then you can use an implementation guide to actually publish that and make sure that the rest of your community implements FHIR in the same way. Just to briefly mention it, so I contributed to the FHIR for FHIR implementation guide, and this part is included in that guide as a example, so a real world case. If you go to this link, you can look at the guide and get more information. A couple of take-home messages. So as I said, I think FHIR can provide the foundation for implementing the FHIR principles. So if you ever come across a situation where you have to implement the principles, then FHIR could be the foundation for that. You would still have to make choices, especially in terms of metadata. Where do you store the metadata? But also, how do you make sure that your metadata is persistent? Implementation guides can help for that. And well, this last one, I think, is very important and maybe very obvious, but important to mention. your data needs to fit within the scope of FHIR. So FHIR is really used in many different research areas. But if your data doesn't fit the healthcare domain, doesn't fit FHIR, then FHIR isn't going to be for you. So you can reach me at the Wova app. I put my email address on here and my LinkedIn URL. And that's about it. We got time for Q&A.
Nice. Thank you very much, Philip. We indeed have some time for Q&A. So if there are any questions from the audience, let me know. Yeah, nice. Coming to watch.
Yeah, thanks for that talk. I was wondering if you mentioned the provenance resource and mapping mimic ED into FHIR, and I wondered how you use that in there, or if you did it exactly.
Yeah. So in this case, there was no provenance information in mimic itself, so I didn't use it. I mentioned it just in case, but in this case, I didn't use it. No.
Okay. Yeah, just curious. Yeah.
Okay, so I haven't seen any question from the online attendees. Is there anyone else in the room? Oh, yeah. Here we go.
Thank you for the presentation, Philip. So you illustrated how the FHIR letters were implemented using FHIR. Can you give an example? So this is how FHIR helps to be fair, right? That's how I read this.
Exactly. Yeah.
So, but is there also not an example of the other way around where you can say that FHIR has helped shape FHIR?
Right. Yeah, that's an interesting question. There are, I think, in the implementation guide, a couple of mentions of this, especially. So yeah, let me think. Yeah, it's interesting. So especially metadata. So FHIR says that your metadata should be completely separate from your data. While if you use FHIR, kind of the resources itself also contain metadata. Parts of the description of your data is in the resources. So it's hard to separate that. And that the citation resource was added, that was actually great, because that gives you the opportunity to, or gives you the possibility to put part of your more generic metadata in that resource, put it in there. I don't have, an example of how FHIR could be improved to make it more fair, like the other way around, but yeah.
So why does FHIR require the metadata to be completely separate from the actual data?
Right. Well, imagine that the data isn't open, for example. That means that if you want to do research and you still want to know what data is available, so without actually accessing the data, you should be able to say, oh, this data contains the information that I'm looking for. If you want to do that, you need the metadata to be separate from the data. Yeah.
Okay, maybe we have time for one last question.
So I noticed when you went through accessibility, you didn't mention much about authentication and authorization.
Right.
Did you find Smart on FHIR lacking there?
I didn't look into Smart on FHIR, to be honest. And also I haven't looked into much into doing authentication and authorization using a FHIR server. So I don't have a direct answer to that, but I think it's definitely something to look into, especially if you're going to do this on a larger scale. So I just give an example here using one data set, but in the real world, you would have many data sets, all want to serve those through a FHIR server, for example. Then this is becoming very important. Yeah.
Okay, everyone, it's about time. So thank you very much for joining. And in about 5 minutes, we have the closing session in the ballroom downstairs. So thanks. Give an applause to Philip.